Okay, so welcome again. What we are going to do in this video is apply some of the probability rules that were introduced in the previous video um, to answer some slightly more complicated questions. And so the strategy that we're going to use to answer those questions will be to make a two-way table. So, for an example, we are given this, of course, hypothetical survey of customers where 8% are dissatisfied with the plumbing jobs in their home, 44% of the plumbing jobs are done by Bros. Plumbing, and 6% of customers had Mario Bros. Plumbing do the job and were dissatisfied. So before we actually do anything else, I'm going to come down here to look at some possible questions for this. So we might be interested in finding the probability that a customer selected at random was dissatisfied or had their job done by Mario Bros. We might be interested in the probability that a customer selected at random was satisfied and did use Mario Bros. Or we might be interested in this third conditional probability. This first one, I think you can answer using one of the rules that we discussed in a straightforward way. But these bottom two are a little less direct. And so that's really where this two-way table is going to come in handy. So, first things first, though, I think a great strategy, no matter what or whether or not you're using a two-way table, is to put down some of the information that we have in notation. So we have the probability that a customer is dissatisfied. We're given that that is 0.08. We are also given the probability that a plumbing job was done by Mario Bros. Plumbing, and we're given that that's 0.44. And we're given that the probability of being, let's see, so being dissatisfied and the job was done by Mario Bros. Plumbing, we have that that is 0.06. So that's what we've got. And again, just writing this out, I think it's easy to answer now this first question. But the other two are a little bit harder. And so what we're going to do is make a little two-way table. And so these tables are constructed where you put one of the things of interest on the columns. And so I'm going to put dissatisfied, and then the complement of dissatisfied. And then Mario Bros. And its complement are going to go on the rows. And so we'll end up constructing this table. And we'll fill in some information. And so what makes up the body of the table are a bunch of intersections. And so, for example, we're given that D and M, the probability of that happening is 0.06. So that goes into the row with M and the column with D. We're also given that the probability of a customer being dissatisfied at all is 0.08. That's what's called a marginal probability, and so it goes on one of the margins of the table. And same with the probability of Mario Bros. Plumbing being 0.44. That goes in the row with the M. So this is the information that we're given. I'm going to change colors to show that we're now filling in new information now. And really what you're taking advantage of here is the fact that the sum of the columns, so this cell that I just put a little dot next to there, and this other cell, those have to sum together to be 0.08. And so that lets us figure out that, okay, if that's true, then D and M complement, the probability of that has to be 0.02. Same logic for the rows. So 44% used Mario Bros. 6% of those were dissatisfied. So that means the other 38% were not dissatisfied. And then the rest we can continue to fill in using a straightforward application of the complement rule. So if the probability of M is 0.44, the probability of M bar has to be 0.56. The probability of being dissatisfied is 0.08. The probability of that complement, D bar, is 0.92. And then we've got a bunch of ways that we could fill in this last cell. The easiest mental math is to do 0.56 minus 0.02, and so that is 0.54. The reason we've done this is that now, especially these bottom two questions that I've put X's on, they are so much easier to answer now that we have this two-way table. And so I'm actually going to skip over this first one for a second and jump straight to number 2. So the probability that a customer selected at random was satisfied and did use Mario Bros. So that is the probability of D bar intersect M. And again, you can actually figure that out by combining some of our probability rules, but it's now much more straightforward to see that, okay, I'm looking at this cell in the upper right, that is D bar intersect M, and so I just know right away that that probability is 0.38. Similarly, we could find the probability that a customer is satisfied given that they used Mario Bros. So that is the probability of D bar, so the complement of being dissatisfied given M. By our definition of conditional probability, we know that that is the intersection divided by the probability of M. And again, it's once we have the table, we're just grabbing the 0.38 that we just used, dividing by 0.44, which was given to us in the problem, and that turns out to be 0.864. So, given that Mario Bros. Plumbing was involved in the job, the probability of being that the customer was satisfied is fairly high at 0.864. Okay, so we will do this last one as well. So the probability that a customer was dissatisfied or had their job done by Mario Bros. So that is probability of D or M. And again, you can use the additive rule here, and it's and that's in this case is probably the more straightforward way to do it. But I'm going to use this table, and I'm going to just look for any of the cells that where D has occurred or M has occurred, and so that happens in the top left cell. Because both D and M occurred there. That happens in the top right cell. And that happens in the bottom left cell. And so this is just an alternative to the additive rule that you could use. You'd wind up with the same answer if you applied that additive rule. You should still wind up with 0.46. So again, these two-way tables are a strategy that we will use from time to time because it helps simplify, especially problems that have a um, that would kind of have you combine some of those basic probability rules.